think we should be live. Hi everyone, welcome back to Coding with Bharat channel. We had Leetcode Biweekly 125 today, and we are going to discuss it in this particular video, right? Let me see if our live has actually started. Yeah, I think it has. So great, welcome everyone. If you want, you can type in chat hello so that I can see if I'm visible, audible, everything is fine. Let me just test it out. Okay, cool. So we had an interesting 125 bi-weekly contest, right? We had four interesting problems. Uh, yeah, it was graph heavy. Like the last two problems were actually on trees or graph, you could say. But yeah, an interesting contest overall. So let's start with the first problem and directly jump into the discussions, right? So let's go ahead. Start with the first one. So this first problem, if you see what it says, it asks you that okay, you are given an array of n size and a number k. So an array has number k. In one operation, it says you can remove one occurrence of the smallest number. So you pick the smallest number and just remove it. For example, here the smallest number is 1 and you remove it. And you also remove only one occurrence. So it's not like if there are multiple ones, you can all like remove all of them in one go. You actually have to do one by one. Now, what you want to do is you want to calculate the minimum operations, minimum number of steps that you need to do like this, so that all elements of my array which are remaining are greater than or equal to k. So essentially, I want to remove all the elements that are smaller than k, right? So yeah, I hope everyone could solve this problem. So the idea is very simple. So we simply need to one by one look at all the elements that have value smaller than k, right? And simply remove them. So yeah, for example, here if we look at it, 1 is smaller than k, 2 is also smaller than k, this is 10, 3 is also smaller than k, so answer is 3. So simply count the number of elements in the array which are smaller than k, right? So first one is this only. Like in one operation, you can take any element, any smallest element and remove it. So सबसे पहले you will remove one, then you will remove two, then you will remove three. You'll keep on removing till the next element that you can remove is more than or equal to k, right? So yeah, basically you'll be removing every other element which is smaller than k. So if I look at the submission of it also, I'll not be spending much time on this because it was an easier problem. So if I go to the submission, so yeah, the code of it was also like pretty simple. I just need to count how many elements are having value smaller than k. So I'll iterate on my array. I'll check if my element is smaller than k. If yes, then I'll do count plus plus, and finally I'll return the count. So a simple brute force code, just one loop over the array and count the number of elements that are smaller than k. If I talk about time complexity of this, so you'll see that this is in fact going to be O of n only. We are just having one single loop, so O of n, and space we are not using any extra, so O of 1, right? So O of n time, O of 1 space. I hope this is clear to everyone. Just quickly type in a yes, those of you who are here for the first problem. Simply go over the array and count the number of elements smaller than k. If you have any doubt, you can just post it in the chat and I'll try to address them, right? Then we'll move on to the second problem. If it is clear, then just type in a yes and we'll move on to the second problem. Okay. Even later, if you feel you need to ask something from a previous problem, please go ahead and ask it. I try to answer it whenever I can. Okay. So second problem of it was a different variation, but dealt with similar ideas. Hmm, just check if my stream is okay. You can feel the stuff. Okay. It is fine. Okay, cool. So the second question, if you think it is very similar to the first one, just a minor change. And what was that minor change? That this time it said you want to pick two smallest integers this time, x and y, and remove them, and you would put in minimum of x and y into 2 plus maximum. So if x is the smallest one, y is the second smallest one, then you'll actually do x into 2 plus y and put it back into your array. So you again need to do this till all the elements are greater than k. So the operation has slightly changed. In the previous one, it was just removing a single element. Here we are trying to remove two elements. So let me take an example with the help of whiteboard. Okay. So let's say if I have my array like this, 2, 2, 5, 3, 1, 7, and let's say my k is something like 3. Okay. So first step, I'll be removing the smallest two. So what are smallest two? This one and this one. So I'll remove them and I'll put back smallest into 2 plus largest. So 2 plus 1, which is 3 into the array. Right? So I think this is being hidden. Let me just move my foot. Yeah. Or let me do not that, but move the screen itself. Cool. Still, all the elements do not have value greater than equal to k. So next what we can do, again, take the smallest two, which are these two, remove them and add 2 into 2, 4 plus 1, 5 into the array. Right. So brute force idea again would be very simple. What would be the simplest brute force idea? That what I can do, I can repeatedly find two elements from the array, two smallest elements from the array, remove them and push them back into the array. So it's like saying find the two smallest, remove them, and then put it back into the array. What do you think? What is the time complexity of doing this with an array? Like if there is an array, how much time will it take to find the two smallest elements? I have to go over, find the first smallest, and then again go over and the remaining and find the second one, right? Or some idea like that. But can I say the complexity of finding two smallest will be O of n? I'll have to do n steps to find the two smallest ones. Can I get a yes if this makes sense? Then again, removing is also n, and then adding probably is O of 1. So if I in worst case have to do this n times to remove all the elements except 1, then the overall complexity will become n squared. Is this idea making sense to everyone? That how overall time complexity will become n squared? 2 into 2 plus 2 6 पुश करेंगे. मैंने क्या बोला था? मैंने 5 बोल दिया था क्या? Yeah, my bad. This has to be 6 because 2 into 2 plus 2 would be there, and yes, we'll be pushing 6. Right. Great. Thanks to correct me. Yeah. Okay. So this is going to be n square. Does that make sense to everyone? N smallest to ढूंढने के लिए, delete करने के लिए. For that we have n, and we'll keep on doing this n times in worst case. In worst case, what can happen is we have to remove everything and just remain with one element, which is going to increase the value greater than equal to k. So that can happen. So in the worst case, we'll remove n minus 1 elements. Here can be used multiset. Yes, yes. I'll explain all the different possible ideas. Yeah, I chose the worst possible way to solve this problem. Oh, okay. Cool. So now, see, I'll tell you the basis of problem solving. So in basis of problem solving, you need to look at what is the operation that you can do faster. So here, what operations we are doing? Finding the smallest, deleting, and adding. Can I do these three operations very easily with a data structure? Just think about it once. Is there any data structure which helps us find the smallest very quickly, add elements very quickly, and remove elements also very quickly in lesser time? What do you think? Anyone who would like to take a shot? What is a data structure which can help us do these operations very quickly? So that is your heap. So if you remember, the min heap, it puts your element, the minimum element at the top. And the way to implement heap, we have our priority queue in most of the languages, right? Priority queue in most of the languages. So we can simply leverage a priority queue here, which is a data structure available in most languages, and that will automatically put the smallest element at the front, will take to calculate the result and push the element back till the smallest element is also greater than or equal to k. Is this idea making sense? How priority queue or min heap can help here? Yes, min heap slash priority queue, they are giving these operations very quickly. Okay. Someone has talked about set also, which is very fair. Set data structure in most of the languages. Not the hash set, but the ordered set, or the, if you are using Java, tree set, or if you are using C++, then ordinary set, right? Or if you are using Python, I don't know, like there would be a set in Python also, which is ordered in nature, right? So basically, the kind of set which is ordered in nature, that automatically puts your smallest element at the beginning. But can you come up with a problem with set? Using set for solving this problem? Anyone who can think of a problem using sets here? So we want to repeat this. Find the smallest two, remove them, calculate the relevant value, and push it back into the data structure. So instead of using an array, we are now coming to ordered set. So do you see any issue with ordered set here? Using an ordered set here? Anyone who can put it in the chat? Let's make it a discussion instead of just my monologue. Very good. So another property of sets is that it removes duplicates, right? It removes duplicates. It will only keep one variation of a duplicate. So initially, if I put all these elements in a set, then these two ones will be combined into a single one, and that is a problem. So we have another variation of set in most languages known as a multi-set. So what we can do, we can use multi-set here that ensures that even duplicates stay as multiple values in the set-like structure, right? So yeah, I don't know, like if Java also has something like tree multi-set, you might have to check it out. But in C++ at least, we have multi-set available with us for our leverage. Does that make sense to everyone? Yes or no? Why we have to go for a multi-set and not a set, right? So our pseudocode would look something like this. Let's say we have a multi-set. We'll add all the elements to it of our array. So just take all the elements of the array and put it into the multi-set. So automatically, multi-set would bring smaller values to the front, right? Smaller values to the front. Now what you can do is till the begin of multi-set, the front of multi-set, that has a value less than k. You take two elements out, do 2 into x plus y, and put it back into the multiset, right? So every time, so first add all the elements to the multiset, smallest will come in the front. Now every time take two elements out, calculate this result and push the result back into the set. So actually if you look at it, after every one step, we are doing removing two elements, adding one element. So in a way, number of elements will reduce by one. So this at max will run n times, and all the operations here are simply log of n. So n log n would become our time complexity. Does this idea make sense? How we have reduced it to n log n using multiset? Even if there is not a multiset in Java, you can probably go for a priority queue, right? I definitely know that priority queue exists in Java, and it's much easier to build compared to C++, where you have to write vector int, greater int, whatever, right? Okay. Is this idea making sense? So add all the elements to the multiset. Every time take two elements out, calculate this, put it back. Till the time start of the multiset is less than k. Till the time we need to remove elements. Okay. And then obviously do count plus plus and return the count. So let's also look at quickly the code. If everyone is here so far, let me go to my submissions and let's look at the accepted one. Cool. So what I've done, I've declared a multi-set of long long. So remember, because we are doing this 2 into x plus y, things can go out of bound, right? So 2 into something plus y. If I do it multiple times, it may happen that it becomes long long. Although I'm not very sure if long long will happen, but yeah, like I think it was failing because of like I must have calculated why we need long long. Okay, so I have created a multi-set of long long. Now what I'm doing is inserting all the elements to this multi-set. So iterating on the array, inserting everything into multi-set. Declare count as 0 till the time the element at the beginning of the set is less than k. You take the element out, erase it. You again take another element out, erase it. Calculate 2 into x plus y and insert it and do count plus plus. So exactly what I told. Every time till the beginning of the array is within k, take two elements out, erase them from the multi-set, and insert the calculated value back into the set. So finally you'll have the count. Is this idea making sense to everyone? Yes or no? So this is any operation in multi-set is log n. So these operations are all log n, and we do this n times. So n log n. Can I get a yes, no, repeat, doubts, anything in chat? If the second question is absolutely clear or not. Once I get sufficient yes, I'll probably move on to the third one. Okay, perfect. Anyone having any questions, please let me know with the second problem. Can you please repeat it? Sure, sure. I'll happily repeat it. Did you understand the logic, Tanuj? You understood the logic? So idea was take two elements out, remove it, and push the result back. So I said to add and find the smallest quickly, we can use multi-set, right? That was the main idea. So what I've written in the code, iterate on the array, put everything into multi-set. So, so in the multi-set, I have all the elements. What is a multi-set? It's a set which supports duplicate also. Problem with set was that we cannot support duplicates. Now what I'm doing is till the time, if I look at the beginning of the multi-set, the value is less than k. That means there is at least one value less than k. So I'll take two values out. So Take the first value out, erase it. Take the second value out, erase it. Calculate this value 2 into x plus y and insert it back. So insert one value back and then do count plus plus because you have done one operation. This is exactly one operation. Take the two smallest out and push this value back, right? Please explain m dot begin, right? So what happens? You know array, right? What is vector dot begin? Vector dot begin is the first element. Yes or no? Right? Vector dot begin is first element. Similarly, m dot begin is the first element of multiset, which is essentially your smallest one. So m dot begin will always give you the smallest element. Is that okay? Ungar, what is m dot begin for? Special property of multiset is it keeps the values sorted from smallest to largest. Cool. Great. I hope now this is clear to everyone. We can move on to the third one. Yeah, it's an iterator. It's an iterator to the beginning of the multiset. Okay. Cool. Third one. Okay. Uh, so from here on, the problems actually became quite interesting. Second one was also very interesting, I would say, compared to some recent contests. So in this one, it says our insert operation is O1 if it is also duplicate element. It's not O1, it's log n, right? Because it's ordered. The way it is implemented is using balanced binary search tree. Do you know about balanced binary search tree? If not, just go and read about it. There are variations of balanced binary search tree which happens to handle duplicate as well, which are being used by multisets. Okay, cool. Let's move on to the third one. So in the third one, it initially said that okay, you are given a unrooted weighted tree. So if we look at it, we are given a tree which is weighted. Weighted means each of the edges have some edge value associated to it, right? So we are given a weighted tree. Now, okay, we are given a weighted tree. Now it says two servers A and B are connectable. So it defines the term connectable. Two servers are connectable through a server C if what happens? Distance from C to A. Distance, what is distance from A to B? It's the sum of the nodes in the map, sum of the edges in the map. Signal speed, a new integer which is given. Distance from C to B is also divisible by signal speed, and the path is not same. So let's evaluate this further. What does this actually mean, right? So let me go to my whiteboard. Okay. So yeah, basically it says, let's say we are given a tree. Okay. Now, it defines the term connectable. What does connectable means? Connectable means that okay, C is a node which connects A and B. C is a node which connects A and B, right? There could be more nodes in the middle, such that sum of paths from A to C is divisible by a variable given signal speed. So let's say if signal speed is 2, so that means this path sum should be even. Similarly, C to B should also be divisible by the signal speed. So this is the first condition, that a node C is called a connectable of A and B if A to C sum is divisible by this signal speed and B to C sum is also divisible by this signal speed. Third point, it says there are no common edges. So why is it that, why is something like that given? So if this is, let's say, your A, right, and let's say this is your B, and you try to make this as C,
it will not work, because even though if these sums are divisible by signal speed, there is a common edge in the middle. Does that make sense? Yes or no? What is the point of the third statement? So let's read the third statement again quickly. Like last statement, the path from C to B and the path from C to A should not share an edge. So path from C to B and C to A, they should not share an edge. So that is why this case is not possible. Does that make sense to everyone? What is the meaning of the last statement? Path from C to A and path from C to B. Can I get a yes? Okay. If that is clear, tell me one thing. Let's say one node has a branch, lot of nodes here. Can it happen that we select A and B both from the same branch of C? So let's say this is my C that I'm trying to build. Can A and B belong both to the same sub branch? Please repeat. I'll repeat. So basically question says given a tree every edge has a weight. That is first point. It says a node connects two nodes if what happens, A to C distance is divisible by some value S, B to C the total distance again divides S, and there is not a common edge between these two paths. That is the main thing, right? So I'm asking you a question. If this is my C, this is the C that I'm trying to build, can I take both A and B from the same branch? So let's say it has multiple branches. Can I take both the values from this same branch? Answer for that is no. Why? Because A to C path will go through this. B to C path will also go through this connecting edge. Yes or no? So both A and B cannot be from the same branch of C. Does that make sense to everyone? Yes or no? That if this is my C, this is the C that I'm trying to put as of now, then my A and B cannot lie in the same branch. Is this making sense? Uh, if it is making sense, can I get a yes in the chat? Or if you have questions, please ask or repeat, then ask for a repeat. It cannot be from the same branch, both A and B. Okay. Now, will it ever be a problem if they are from different branch? Just think about it. Will it ever be a problem with this? Will this last condition ever be a problem if they are from different branch? So answer is no, because whatever path we take from A and whatever path we take from B, they are going to be very, very different. Is this making sense or not? Yes or no? So whichever node we are trying to make a center, whichever node we are trying to make a center, we need to find how many pair of such nodes occur such that they are on different branches. So let me just write it just to be clear. So whatever is our center C, we need to find how many pairs are there A comma B such that they are from different branches. First of all, they should be from different branches. Second, A to C is divisible by S and B to C is also divisible by S. Does that make sense to everyone? Yes or no? तो ऐसे कितने पेयर हैं सच दैट वो दोनों पेयर डिफरेंट ब्रांचेस में है और C से उनका डिस्टेंस दोनों का डिस्टेंस डिविजिबल बाय S है. Is this making sense? What we need to do in this question? And this we need to do for every center C that we take. Can I get a yes or no? And then एक एग्जाम्पल के साथ और एक्सप्लेन करूंगा. Like if overall idea is making sense, what do we need to do here? Okay, so let us take one of the examples of the question as well. Let's take this one, right? So this is our 3 in the middle, right? And what is our S? Signal speed 3. So we need to look at those edges, those nodes where we can reach with value divisible by 3, right? ठीक है. So अभी के लिए 3 को सेंटर मानते हैं. We'll try to make other places also as center, but अभी के लिए let's make 3 as center. So if I look at the first branch is 3 to 0, 0 to 6, 6 to 5. How many nodes are there such that वहां तक का distance divisible by 3 है? How many nodes are there in this branch 3065 till where the sum of the distances is divisible by 3? Can you tell me how many nodes can you see till where the sum of the distance is divisible by 3? Distance till 0, 1. Is it divisible by 3? No. Distance till 6, 3 plus 1, 4. Is it divisible by 3? No. Distance till 5, 3 plus 3, 6 plus 1, 7. Again, not divisible. 3 to 4 also not divisible. 3 to 7, 3 to 2 also not divisible. 3 to 1 is the only one which is divisible. Can everyone see that? Okay, everyone is saying 2 or 3. 2 और 3 कैसे है? 3 से 0 तक कितना डिस्टेंस है? 1. Is it divisible? No. It is not divisible by this S. 3 to 6, 4. Again not divisible. 3 to 5, 7. Again not divisible. Can you see that? There is only one node from 3. One node from 3 which has a distance divisible by 3. 3 to 1. Can everyone see that? 3 to 1 ही इकलौता edge है, right? So with 3 as center, we only have one element in one branch. So answer is 0. You can also see that. 1, 2, 3, right? So answer is 0. Let's take 0 now. 0 को center बनाते हैं. 0 को center बनाते हैं. Now, in the first branch, there are two nodes, 3 and 3 plus 3, 6. So, दो nodes हैं, 6 and 5, which have distance divisible by 3. Can everyone see that? इसको मैं copy करता हूँ वहाँ पे, and then we'll also see. So, we have 0. 0 की अगर first branch देखते हैं, 0 की first branch देखते हैं, तो 3 distance पे 6 है and 3 distance पे 5 है. तो ये दोनों नोड जो हैं डिस्टेंस 3 और डिस्टेंस 6 पे हैं. So both of them qualify as possible nodes. Yes or no? But can I take 5 and 6 both? What do you think? In the same case. Yeah. Can I take 5 and 6 both? Yes, no? What do you think? Are 5 and 6 in the same branch or in different branch? No, right? We cannot. Because they are in the same branch. ठीक है, let's look at the next branch. अगली जो branch है 3, we have distance 1. Then 4, we have distance 2. Then 2, we have distance 7. And then 1, we have distance 6. Okay. अब In the second branch, how many nodes are there which have distance divisible by 3? So node number 3, total distance is 1. 0 से distance कितना है 1. So divisible by 3, no. Distance till 4, 2 plus 1, 3. Is divisible? Yes. 1 plus 7, 8. Divisible? No. 1 plus 6, 7. Divisible? No. तो एक ब्रांच में दो नोड्स हैं, दूसरी ब्रांच में एक नोड है. सो या तो ये इसके साथ चला जाए या ये इसके साथ चला जाए. तो टोटल आंसर इज 2. एंड दैट इज व्हाट वी एक्चुअली सी इन आवर टेस्ट केस एज वेल. For answer for 0 is 2. Similarly, you can calculate the result for the last one, which is 6. तो again you will see एक branch में 5 है and एक branch में ये 5 है, दूसरी branch में ये 0 है. तो again 6 5 and 0 हो जाएगा, या फिर 5 and if I look at it then 4. So 3 plus 1 plus 2. So 5 and 4 and 5 and 0 दो cases बन जाएंगे. So that is why answer for 6 also is 2. क्वेश्चन क्लियर है क्या सबको? व्हाट डू वी वांट टू डू इन द क्वेश्चन? तो बेसिकली किसी को भी सेंटर बना के वी वांट टू नो इन ऑल द डिफरेंट ब्रांचेस हाउ मेनी नोड्स आर एट डिस्टेंस डिविजिबल बाय 3 एंड देन यूज दैट टू कैलकुलेट आवर रिजल्ट. वो कैसे कैलकुलेशन होगा उस पर आते हैं, बट इज द आइडिया क्लियर कि करना क्या है? Make everyone as center, try to find how many in each branch are having distance divisible by this signal speed, and then use that answer somehow to calculate the total result for the current value, right? A quick yes if so far things make sense, then I'll move on. Also, if you are here, if you can like the video, it would be helpful for the channel as well. Okay, cool. तो अब इसका थोड़ा solutioning डिस्कस करते हैं. What do we want to do? Cool. The first problem here is for every branch, for every center C, for every branch, I want to count how many are at distance divisible by S. Can I do that easily? What do you think? क्या मैं हर ब्रांच के लिए निकाल सकता हूँ कि कितने ऐसे नोड हैं जिनका डिस्टेंस डिविजिबल बाय दिस सिग्नल स्पीड है? इजीली. सो व्हाट आई कैन डू इज, जो भी मेरा सेंटर है I can keep on passing the distance down, right? And collect how many have distance divisible by signal speed back, right? तो basically एक DFS से one DFS from the center would give us this result, that for every branch how many are having distance divisible by this S. Okay, इसका और इम्प्लीमेंटेशन में दिखा दूंगा, बट लाइक आई एम वेरी श्योर दैट सम ऑफ यू हैव डन ट्री क्वेश्चंस, देन यू वुड नो हाउ टू डू दिस, राइट? नहीं भी करें तो कोई बात नहीं, अभी समझ लेंगे. बट इट्स बेसिकली रिकर्शन, राइट? दैट वेन एवर यू आर गोइंग डाउन you pass the new distance down down down, and then you collect the results. If the current node is also to be added, you do plus plus and then return. So we'll see that in the code as well, right? नेक्स्ट इंपॉर्टेंट पॉइंट इज, ठीक है, नाउ वी हैव द सेंटर, वी नो कि एक ब्रांच से लेट से दो नोड्स हैं, एक और ब्रांच से 3 नोड्स हैं, एक और ब्रांच से एक ही नोड है, एक और ब्रांच से लेट से 2 नोड्स हैं. हाउ टू कैलकुलेट द रिजल्ट फॉर दिस सी, राइट? दिस इज द ट्रिकिएस्ट पार्ट दैट आई वुड से. सो जस्ट पे अटेंशन, right? So if you think about it, with every node in this branch, इस ब्रांच के हर नोड के साथ I can try to take the second node from any of the other branches. Yes or no? ये समझ में आ रहा है क्या? अगर यहाँ पे मैंने A रखा है तो my B can be anywhere in this. Yes or no? So for these two nodes, we can make a pair with any of these 3 plus 2, 5 plus 1, 6 nodes. Is this idea making sense? इसमें से अगर मैं A मानता हूं तो इन सब में से कोई भी हो सकता है. Similarly, if I take A from this 3, then my B can be in any of these. So 2 plus 2, 4 plus 1, 5. So 3 into 5, 15. And similarly, you can do calculation for the others. So for any branch, if you are picking A from that branch, you can pick B from any of the other branches. So number of nodes will distance divisible by S in A branch into number of nodes indivisible in all the other branches. That is what you would need to add up for every branch. ये आइडिया समझ में आ रहा है क्या कि 2 के साथ ये सारे, 3 के साथ ये सब, 1 के साथ फिर बाकी बचे हुए, एंड 2 के साथ अगेन everyone, right? So in a way the answer would look something like, with 2 I'll take 3 plus 1 plus 2, with 3 I'll take 2 plus 2 plus 1, then with 1 again I'll take 2 plus 2 plus 3, and lastly with the last two also I'll take 2 plus 3 plus 1. So for every A, हर ब्रांच से अगर ले लें तो दूसरों से B ले सकते हैं. The problem here is, do you see repetitions? Let me know यहाँ तक क्लियर हुआ क्या, and do you see repetitions in this? क्या यहाँ पे लग रहा है repetition आएंगी? Okay, तो there is a chance of repetition. Why? अगर यहाँ A है तो मैं इनमें से कहीं भी B डाल रहा हूं, बट जब इनमें से कहीं A होगा तब भी मैं यहाँ B डालूंगा, तो एक तरह से every pair would be counted twice. तो एंड में इस पूरी चीज को मुझे डिवाइड बाय 2 करना है, बिकॉज एवरी पेयर वुड बी काउंटेड ट्वाइस. सो दैट इज द मेन क्रक्स ऑफ द क्वेश्चन. तो मैं एक बार रिपीट करता हूं. यू ट्राई टू मेक एवरी नोड एज सेंटर. अब किसी नोड को सेंटर बना दिया तो यू गो टू ऑल इट्स ब्रांचेस, कैलकुलेट हाउ मेनी नोड्स इन दैट ब्रांच हैव distance sum divisible by your speed, signal speed. You get that count, and then with those counts you need to do this kind of computation, that with every node you multiply some of the other branches value and add it up and then divide it by 2. So let's see it in code form as well. तो इसका code थोड़ा सा complicated है, considering that there is DFS, there is math, there is a lot of things, right? So let's just do that. Let's go to the code, but it's quite intuitive. The way that I think I have written it, it should be quite intuitive. Okay. Cool. So first thing, what do we have in this edges? We have like pair, like 3 values, right? A, B and weight. And this is our signal speed. So first thing that I've done, I've declared my result vector of size n plus 1. So if number of edges are n, then actual number of nodes are n plus 1. So that is why plus 1 is here, right? Everyone knows this, right? अगर एक ट्री में n nodes हैं तो उसमें एक कम number of edges होते हैं. So whatever is the number of edges, we need to do plus 1 to actually get the number of nodes. Yes or no? N edges matlab n plus 1 nodes. So that is why this is plus 1, because we need to calculate the answer for every node, each of the n nodes. Okay, I have declared adjacency, I have declared the weight vector. So what I've done, basically this is the part to create the graph. तो ग्राफ में मैंने क्या किया है, एडजेसेंसी ऑफ 0 में 1 डाल दिया, एडजेसेंसी ऑफ 1 में 0 डाल दिया, देन सिमिलरली कंप्यूटेड दिस वेट, कि अब वेट ऑफ 0 में भी सेकेंड वैल्यू डाल दी एंड वेट ऑफ 1 भी सेकेंड वैल्यू डाल दी. सो बेसिकली क्रिएटिंग द ग्राफ. सो दिस एडजेसेंसी ऑफ आई जे विल गिव अस कि ith नोड से jth एलिमेंट कौन सा कनेक्टेड है, एंड वेट ऑफ आई जे वुड गिव अस द कॉरस्पॉन्डिंग वेट फॉर दैट एज. आई होप दिस इज मेकिंग सेंस टू एवरीवन कि ग्राफ कैसे बनाया है और ट्री कैसे बनाया है. एक्चुअली दिस इज नॉट अ ग्राफ बट ट्री कैसे बनाया. एडजेसेंसी अगर ये नहीं समझ में आ रहा है तो यू नीड टू गो एंड लर्न एडजेसेंसी लिस्ट वंस, दैट हाउ डू वी क्रिएट एडजेसेंसी लिस्ट्स, राइट. ओके, ठीक है. तो दिस इज द पार्ट ऑफ क्रिएटिंग द अनडायरेक्टेड ग्राफ. यस, अनडायरेक्टेड ग्राफ. नेक्स्ट पार्ट व्हाट आई हैव डन इज I have gone and made every node as center. So as you can see, I less than I0 से n less than n तक चला है. Hs plus 1 is again n. So I've tried to make every node as center. And उसको center बना के I've tried to go over its branches. So adjacency of that node would give me all its branches. And got the result from that branch and pushed it inside this vector v. ठीक है, अभी डीएफएस में जाते हैं अंदर कि व्हाट इज हैपनिंग. लिटिल हार्ड फॉर यू. हाँ, नो वरीज. मतलब इफ यू हैव स्टार्टेड जस्ट, सो इट माइट बी लिटिल हार्ड. ठीक है. एंड स्पेसिफिकली इफ यू हैव नेवर डन ग्राफ और ट्री, देन दिस वुड बी ऑलमोस्ट no, you'll not be able to understand it, right? Yeah. We can also make use of matrix 2D. We can, but actually if you look at it, I think the question said 10 to the power, no, it had 10 to the power 3. Yes, so we can use matrix as well. If you want to use adjacency matrix, you can do that, right? Okay, but I've used list. Cool. Coming here, so this part is fixing your center. So this will fix your center, that okay, what is the center of the tree that I'm trying to take at the moment. And I'll make a DFS call for all its branches and collect those values in this vector. So I have done v dot pushback, call the DFS for the jth branch. ठीक है, अभी DFS पे जाते हैं कि what it is doing, but I'm assuming that this DFS call would give me the result and I'll push it into the vector. Does this make sense? A less than B condition. हाँ, A less than B condition कैसे satisfy हो रही है? अगर if you remember, हमने ये बाई टू करा है. बाई टू से क्या होगा, किसी भी ए के साथ जब बी आ रहा था तो हमने बी के साथ भी ए लिया होगा. सो वी हैव एक्चुअली टेकन ऑल दी पॉसिबल पेयर्स. आउट ऑफ दैट वन पेयर विल बी वैलिड, वन पेयर विल बी इनवैलिड, बिकॉज स्मॉलर से बिगर वैलिड होगा, बिगर से स्मॉलर वैलिड नहीं होगा. डज दैट मेक सेंस? दैट इज वाई बाई टू करा है लास्ट में नंबर ऑफ फेज में. ओके रोहन, ए लेस देन बी वैसे वैलिड हो रहा है. कूल, लेट मी गो बैक टू द कोड. Why we create weight vector? Normally we create only adjacency list because ये weighted tree है. So if you have tried to write Dijkstra in the past, right? So when you have to create a weighted tree, let me connect my battery to the laptop. Okay. So I think we should be back. Let me see if we are back. I think we should be back. Let me just quickly check out if we are back. And I'm not connected. Okay, this is connected. This one is not connected. Oh my god. Okay. Okay. Sorry guys for the disruption and thanks for sticking by. Yeah. So as I was explaining, right. So someone has asked why we are creating weight array. So again, the idea is very simple. When we write even Dijkstra, we cannot just create adjacency list, because adjacency list then would contain that okay, 2 is connected to 3. But the connection from 2 to 3, what is the weight of it? That is also important. So one way that some people do is create a pair here. So instead of just putting the value, they put value and the weight. So if you want, you can do that. Instead of that, what I've done is I've just created two different vectors. One would store the just the connections. Second would store the weights for the corresponding connections. Does that make sense? What is this weight array for? What is the weight array for? Is that clear? Okay. Coming back to here. So what I've done, I have gone through all the nodes, made the center, then pushed into the vector the value for each of their branches, right? And now if I have, okay, in each branch, what is the number of nodes? I have stored the value in count of I as calculate total. So अभी main part जो रह गया DFS और calculate total. But this is the overall structure of the code, right? तो अगर यहाँ तक समझ में आ रहा है तो let me know, and then I'll look into each of the individual functions of DFS and calculate total. Yep. हाँ तो pair also can be used. Pair and this is very similar. I just like to keep the vectors alag alag, but if you want, you can put it in one vector itself. I'm an expert at CF. All the grid code questions are getting easier for me. Shall I continue doing it or just stick to CF and target CM? Uh, if these are easy, then just go ahead and like go for code forces, right? Is what would be my suggestion. Okay. Anyways, coming back from here, यहाँ तक क्लियर है क्या ओवरऑल स्ट्रक्चर ऑफ द कोड? देन वील गो इनटू डीएफएस कि डीएफएस कैसे इंप्लीमेंट हुआ है, like how do we calculate for each branch how many nodes are divisible, having total weight divisible by the signal speed, and also look at the calculate total function which does our maths. Okay, ठीक है. So let's look at DFS. तो DFS में हम क्या कर रहे हैं? DFS में our branch starts at a particular node, right? We have node, we have distance till that node, we have the parent of it, right? We have the adjacency and weight, which is obvious, and we have our k, which is our, you can say, s or the signal speed, right? So basically what I'm trying to do is ki when I am at any particular node, then this distance variable that we are looking at, that has the distance till that point. So if I go back to my drawing board, so when we were talking about this, so when I reach this 5 from 0, when I am at node 5, when I started at 0, so the distance value when I reach here would be 6. The total distance from 0 till this point, which is 3 plus 3, 6. That is what this distance variable is storing. So for my first call also, I would pass 3 to it, which is the distance of this node, distance of this edge. So if you actually look at the code part of it also, when I am calling for a particular branch, right? So am I calling for a particular branch? Going over the adjacency, calling for a particular branch, adjacency ij. That okay. Let's call for the jth branch. I am passing the weight of ij, which is the connected edge's weight, as the distance, right? तो यहाँ पे जो distance है that stores कि इस node तक पहुंचने में मुझे कितना distance लगा है, right? Is that clear to everyone? What is the distance variable for? Like whatever node you are at, the distance that has been taken to travel till that point from the center से वहां तक कितना distance लगा है. Okay. So what I am doing in this DFS is I am calling further DFS for the further children of this node. So basically going over the adjacency of the node. If it is not same as the parent, then continue. So if it is same as the parent, then continue. Otherwise, store in this answer by calling the child. While calling the child, distance is updated as distance plus the new weight. तो जब भी मैं नोड नंबर ए से नोड नंबर बी जा रहा हूँ, लेट्स से एक्स से वाई जा रहा हूँ, तो वाई जाते हुए उसके बीच का जो डिस्टेंस है वो ऐड करते हुए डिस्टेंस में आगे भेज रहा हूँ, राइट? दिस इज द इंपॉर्टेंट पार्ट कि ये डिस्टेंस यहाँ पे ऐड होके जा रहा है. लास्ट में अब मैं क्या कर रहा हूँ कि इफ टिल दिस पॉइंट दिस नोड इटसेल्फ द डिस्टेंस इज डिविजिबल बाय एस, देन डू आंसर प्लस वन. एक और नोड मिल गया मुझे, ये करंट वाला. अदरवाइज जस्ट रिटर्न आंसर. सो दिस इज द डीएफएस आइडिया. तो डीएफएस में क्या कर रहे हैं, जिस भी नोड से ब्रांच स्टार्ट हो रही है, आई एम कॉलिंग फॉर द रिमेनिंग वंस, उनके आंसर्स में प्लस कर दे रहा हूं और इस खुद नोड को देख रहा हूं कि क्या यहां तक का डिस्टेंस भी एस से डिविजिबल था. इफ यस, देन ये नोड भी आंसर में होगा, तो आंसर प्लस वन. अदरवाइज सिंपली रिटर्न आंसर. इज दिस डीएफएस मेकिंग सेंस दैट व्हाट वी आर ट्राइंग टू डू हियर? यस, नो? तो एक तरह से डिस्टेंस ऊपर से नीचे ट्रैवल हो रहा है एंड नंबर ऑफ नोड्स बॉटम अप ट्रैवल हो रहे हैं कि हाउ मेनी नंबर ऑफ नोड्स आर देयर. इफ यू वांट टू सिंप्लीफाई इट, तो एक और तरीका हो सकता था कि वी हैव अ वेक्टर एंड स्टोर डिस्टेंस ऑफ एवरी नोड इन दैट वेक्टर, राइट? सो उस तरह का कुछ कर सकते थे, बट अगेन दैट वुड हैव बीन टू मच कॉम्प्लिकेशन आई गेस. कूल. लेट्स लुक एट द कैलकुलेट टोटल. तो अब बेसिकली यहां तक क्या हो गया, किसी भी नोड को सेंटर मानते हुए हर ब्रांच में कितने नोड्स हैं वो मेरे इस वेक्टर में आ गए. अब आई वॉन्ट टू डू द कैलकुलेशन. सो मैंने कैलकुलेशन में क्या बोला था, एवरी नोड्स वैल्यू इज मल्टीप्लाइड बाय सम ऑफ द रिमेनिंग. सो मैंने क्या किया, सबका सम ले लिया पहले, टेकन एवरी वन सम, एंड देन आई एम एडिंग टू दिस सम आंसर टोटल सम माइनस द करंट वैल्यू इनटू करंट वैल्यू. तो करंट वैल्यू में ए रखेंगे और बाकी सब में बी रखेंगे और उसको आंसर में ऐड कर देंगे, एंड फाइनली आंसर बाय टू. इज दिस मेकिंग सेंस? हमने वो देखा था ना, टू के साथ बाकी सबका सम, फिर थ्री के साथ बाकी सबका सम, फिर फोर के साथ बाकी सबका सम. दैट इज व्हाट वी आर डूइंग हियर. एवरी वन सम इज इन दिस वेरिएबल, देन फॉर एवरी वैल्यू we are doing that value into everyone else. So sum minus this value. Is this code making sense? I'll explain DFS again, don't worry. But is this part making sense? Calculate total. Then I'll move on and talk about the DFS again. Just to repeat. Yes, no? We were saying that the node can be counted twice. How? पहली बात तो हम नोड काउंट नहीं कर रहे, राइट? वी आर काउंटिंग पेयर्स. You agree with that? We are counting pairs A and B pair. So I am saying, let's say A and B two nodes are in branch X and branch Y. राइट? तो जब मैं x के लिए आंसर निकाल रहा हूं, तब उसके साथ मैं इस y को कंसिडर करूंगा। एंड फिर जब मैं y के लिए आंसर निकाल रहा हूं, तब मैं x को भी कंसिडर करूंगा। तो एक्स वाई भी काउंट हो जाएगा, वाई एक्स भी काउंट हो जाएगा। पर क्वेश्चन में क्लियरली लिखा था कि एक ही बार काउंट करना है। डज दैट मेक सेंस? तो इसीलिए बाई टू करें, बिकॉज एवरी पेयर वुड बी काउंटेड ट्वाइस। एक बार जब जिस नोड पे हम हैं उसके साथ बाकी सब कंसिडर कर रहे हैं, और दूसरी बार जब तो दूसरा कंसिडर किया है वो फर्स्ट नोड है, एंड हम बाकी सबको सेकंड नोड कंसिडर कर रहे हैं। डज दैट मेक सेंस? कैसे हर पेयर दो बार काउंट होगा? या एक्स वाई एंड वाई एक्स, राइट? उस तरह से पेयर काउंट होंगे दो बार। सो दैट इज वाई दिस डिवाइड बाई टू। इज दैट क्लियर? ओके, एक्सप्लेन डीएफएस अगेन, राइट? तो जनरली देखो, डीएफएस में दो ऑप्शंस होते हैं। आइदर यू डू टॉप डाउन, राइट? टॉप डाउन में क्या होता है? यू अपडेट अ वैल्यू एंड पास इट डाउन, राइट? बॉटम अप में क्या होता है कि यू रिटर्न वैल्यूज। यस और नो? दिस इज व्हाट द मेन आइडिया इज। ठीक है? अगर तुम्हें इसको सिर्फ टॉप डाउन बनाना है, तो व्हाट यू कैन डू इज यू कैन डिक्लेयर अ ग्लोबल वेरिएबल काउंट इक्वल टू जीरो, कि कितने नोड हमें मिल गए, राइट? तो ये आंसर वांसर सब हट जाएगा। विल जस्ट मेक फर्दर डीएफएस कॉल विद द अपडेटेड डिस्टेंस, एंड देन डू दिस चेक कि जिस भी नए नोड पे हम हैं, अगर उसका डिस्टेंस इस के से डिविजिबल है, के इज योर सिग्नल स्पीड, अगर डिस्टेंस के से डिविजिबल है तो काउंट प्लस प्लस कर दो, है ना? अगर काउंट ऊपर ग्लोबल होता तो आई कुड हैव डन काउंट प्लस प्लस एंड देन जस्ट मेड द रिमेनिंग कॉल्स। एक आइडिया ये हो सकता है। मैंने उसके साथ आंसर को भी बॉटम अप में रिटर्न कर दिया है। तो मैंने क्या करा है कि जो फर्दर चिल्ड्रन कॉल्स आ रहे हैं उनसे जो आंसर आ रहे हैं वो इसमें ऐड कर दो, एंड देन इफ योर डिस्टेंस इज डिविजिबल बाय के तो आंसर प्लस वन होगा, वरना आंसर ही होगा। डू यू गेट द आइडिया? तो डिस्टेंस तो टॉप डाउन पास हो रहा है। इफ यू डोंट वांट टू रिटर्न आंसर्स, वो अगर कॉम्प्लिकेटेड लग रहा है, तो यू कैन डिक्लेयर अ ग्लोबल वेरिएबल एंड जस्ट डू काउंट प्लस प्लस व्हेन यू, और आंसर प्लस प्लस व्हेन यू गेट दिस वैल्यू एज जीरो। डज दैट मेक सेंस? वो तुम्हारी मर्जी है, बट ये भी सिंपल टू अंडरस्टैंड ही है कि जो भी चिल्ड्रंस से वैल्यू आ रही है वो मैंने ऐड कर दी, और फिर करंट नोड की वैल्यू देख ली कि अगर करंट नोड तक भी डिस्टेंस के से डिविजिबल है तो एक और मिल गया मुझे करंट नोड। अदरवाइज जो बच्चों से आ रही है आंसर, वही आंसर होगा। ये समझ में आ गया? टू ऑप्शंस। ओके, कूल। If I talk about time complexity, this is O of n. This is actually also O of n. So everything is O of n, right? But this O of n, if you see, this O of n entirety is happening inside a bigger loop of O of n. So actually it is n square. But n square was good enough to pass here because we had n as just 1000. Does that make sense to everyone? N square, time complexity. Space, obviously we are using extra, so O of n to hai space. This would be one difference. एक किसी ने बोला था adjacency matrix we can use. Adjacency matrix will have your n square space, whereas using list has on space. So space will be a difference if we solve this via adjacency list versus matrix. Does that make sense to everyone? यहाँ तक? Then we'll move on to the fourth problem. According to me, fourth was an easier one. I don't know why it was kept fourth, but maybe it was less intuitive. But let's see. पहला क्वेश्चन मैंने बताया आदित्य, यू कैन रिवर्ट बैक, मतलब स्टार्टिंग में चले जाओ, एंड यू विल बी एबल टू सी द फर्स्ट क्वेश्चन ऑल्सो। एवरी नोड विजिट ट्वाइस, ये दोबारा बताऊं क्या दयाशंकर? शुड आई एक्सप्लेन इट अगेन? एवरी नोड ट्वाइस। अच्छा, every node twice बोल रहे हो, okay okay, I thought that you were talking about AB concept. ठीक है sorry. Every node, yeah, will be visited twice. Once, yeah, in this TFS, second while calculation. Cool. Let's move on to the fourth and final problem, right? Okay. So this fourth and final problem, what did it say? It again gave you a tree, right? Again gave you a tree. And what it did was it said that in every operation what you can do is you can choose an edge u comma v. ठीक है, कोई भी edge u comma v choose कर सकते हो. And you can replace value of u with value of u xor k, and value of v also with value of v dot xor k. So as an example, in this, what I can do, I can choose this 0 and 1 and XOR both of them with k. So 3 XOR 1 क्या होगा 2, and 3 XOR 0 will make it 3. What? 1 second. अच्छा नहीं, 0 1 2 तो इनके इंडाइसेस हैं, एक्चुअल वैल्यूज आर 1 2 1. सो यहाँ पे 1 है, यहाँ पे 2 है और यहाँ पे 1 है. So what I can do is I can pick this edge 0 comma 2, replace this also with 1s or 3 which is 2, replace this also with 1s or 3 which is 2, and I'll get 2 2 2 which is 6. एक बार मैं उस पर एक्सप्लेन कर देता हूँ वाइट बोर्ड पे. एक बार a लेस देन b वाला कंसेप्ट, हाँ मैं एक बार वो दोबारा बताता हूँ. पहले ये फोर्थ खत्म कर लें, इफ दैट इज ओके. व्हाट हैपेंड, नॉट एबल टू टेक दिस. 1 second, I need to probably remove this and add window capture. Sorry, yeah, some technical issues that we would need to bear. Right. Right. So now I think it should be visible, the screen. Sorry for these technical problems, and my face is gone now. Let me bring it up. Cool. OBS and all. Cool. Yeah. So coming back to fourth problem. So fourth problem said, let's say we are given a tree, right? So let's take a tree. Let's say each node has some value. So let's say 2 here, 1 here, 1 here, 1 here, 2 here, 1 here. And let's say we have a k3. So what we can do is always we can select any pair of nodes which are adjacent, right? Any pair of nodes which are adjacent and XOR both of them with k. So let's take these two and XOR with k. So 1 XOR 3 will become 2 here. Similarly, 1 XOR 3 will become 2 here. Similarly, I can do with these two. So 1 XOR 3 it becomes 2, 1 XOR 3 it becomes 2. So you can do as many operations as you want, and you want to maximize the sum of all values. So in each operation, what you can do, pick a pair, XOR both the values by k, and do this any number of times, and finally you want sum of the values to be maximum. जैसे अभी यहाँ पे 2 plus 2 plus 2 plus 2 plus 2, this would be the maximum. We cannot get better than this. Does this make sense what the question wants you to do? Any edge, XOR both the values with k, and then do this as many times as you want and maximize the sum. Can I get a yes if this question makes sense? What the question wants you to do? Cool. Azim, I'm still trying to build a rapport like in terms of being able to come live after the contest. Generally, it does at 10. So both the contests start at 8, right? In the morning or in the evening. So I try to come live by 10 in case I attempted the contest and I'm well enough, right? Last 2 weeks I could not, but yeah, this week I'm trying to get back. Okay, cool. Coming back to it. So let us first analyze one thing. Let's say there are two values here, 1, 1, and my k is 3. Can I convert these two values to 2? Tomorrow, most likely, it should be alive. Yep. Can I convert these both ones to 2 with my operations? So answer for that is yes. Let's see how. So what I can do, I can first take these two. So what will happen? This will become 2. This will become 1. Then take these two. This will become 2. This will become 1. Then again take these two. This will become 2. This will become 1. And then again take these two. This will become 2. This will become 2. So actually, if you follow the chain, what is happening? Let's see that. Middle nodes, they are getting XORed 2 times. Yes or no? Can everyone see that? पहले और लास्ट नोड के अलावा बीच के जितने नोड्स हैं वो एक बार जोर पीछे वाले के साथ हो रहे हैं, एक बार आगे वाले के साथ. So they are getting XOR 2 times. Yes or no? Can everyone see that? एक बार बताओ, किसी भी नंबर को 2 बार सेम नंबर से जोर करो तो व्हाट हैपेंस? किसी भी नंबर x को 2 बार अगर सेम नंबर से जोर कर दे तो व्हाट हैपेंस? x XOR k XOR k, what happens? सेम नंबर रहता है. Yes or no? It stays the same. X k और k जीरो जाता है and x और जीरो is x. So 2 बार जोर करने से the number will revert back to its original place. तो can I say this? Whatever the tree is, any two nodes in the tree, I can convert both of them together by doing XOR with k. Because जो भी उनके बीच का पाथ होगा, whatever the path is there in the middle, I'll keep on doing XOR with pair, XOR with pair, XOR with pair. बीच के सारे वापस आ जाएंगे अपनी जगह पे, सिर्फ फर्स्ट और लास्ट चेंज होंगे. इज दिस आइडिया मेकिंग सेंस? कि any two nodes in the tree I can pick and do XOR with both of them. Yes or no? So this leads to an idea कि ट्री का क्या स्ट्रक्चर है, दैट डजेंट मैटर. ट्री से तो कोई फर्क ही नहीं पड़ा. I can simply take any two nodes and do XOR with k. So question becomes, given an array of numbers, you can do an operation by taking any two numbers, right, and doing XOR with them, and then you need to do this as many times as you want, till what happens is you get the maximum sum possible. Is this idea making sense? Ki how we can get rid of tree structure altogether? Just type in a yes if this makes sense. Okay, let me see the chat as well. Okay. अगर ये क्लियर हो रहा है तो लेट मी जस्ट गो टू स्विच. Oh my god, I cannot see the chat for some reason. It's super complicated, this all setup. Cannot see myself as live. Why is it not showing me live? What is all this? Okay. Anyways, like I'm going to wing it then. I am not able to see the chat. So I'll explain the ideas, right? And if it's anything is unclear, just feel free to put it in the comment section and I'll take it up from there, right? So yeah, now because of this idea that any two nodes can be taken, हम किसी भी दो nodes को ले सकते हैं and उनको XOR k कर सकते हैं. So what we can actually do कि ट्री की अब कोई वैल्यू ही नहीं रही, ट्री इज एक्चुअली एब्सोल्युटली यूजलेस. क्वेश्चन बन गया कि एक एरे गिवन है, राइट? वी आर गिवन एन एरे. इन दैट एरे we want to select two numbers and XOR it with k as many times as we want. तो ठीक है, अब ये कैसे करें? So let's go back to our question and look at it also. So पहला केस अगर देखते हैं तो actually what is happening, we have numbers as 1 to 1. So we'll pick this one and this one, XOR with k, so we'll get 2 to 2 and answer will be 6. यहाँ भी देखते हैं 2 है और 3 है, 2s और 7, 2s और 7 एंड 3s और 7 ऐड करोगे तो 9 आ जाएगा. ये वाला केस भी, देन केस 3, सो 3 का इन सब में से किसी के साथ भी XOR करके कोई फायदा नहीं है, राइट? Next thing that I'll say is that if I have a number x, so I need to switch back to my whiteboard. If I have a number x, question is, do I do a XOR with k or do I not do a XOR with k? If I don't do a XOR with k, I'll be adding x to my answer. आंसर में x ऐड होगा. अगर k से XOR करता हूं तो x और k ऐड होगा. ठीक है, तो पहले अज्यूम करते हैं कि हम किसी का भी XOR नहीं करेंगे, तो हमारा आंसर क्या होगा? सम ऑफ एवरीथिंग, राइट? अगर हम डिसाइड करते हैं इफ वी वांट दैट वन ऑफ द नंबर्स वी XOR इट विद k, तो क्या होगा? आंसर में से इन अ वे आई विल सबट्रैक्ट x, क्योंकि ये x हट जाएगा, एंड आई विल ऐड x XOR k. दैट मीन्स इफ आई डिसाइड टू XOR अ नंबर विद k, तो क्या होगा? उसकी वजह से जो कंट्रीब्यूशन होगा दैट वुड बी कि x XOR k ऐड हो जाएगा एंड x माइनस हो जाएगा. तो जिन भी नंबर की वैल्यूज में x और k माइनस x पॉजिटिव होता है, वी कैन पिक दोस, बट वी नीड टू पिक देम इन पेयर्स. तो मैं क्या करूंगा कि मैं सब नंबर्स के लिए ये वैल्यू निकालूंगा कि अगर मैं उनको XOR करता हूं तो मुझे क्या नुकसान होगा या क्या फायदा होगा. दैट इज व्हाट x और k माइनस x, बिकॉज इफ आई XOR देम देन x और k वुड बी एडेड एंड x वुड बी सब्ट्रैक्टेड. इस एरे को द एरे विद दीज वैल्यूज दैट आई क्रिएट, आई विल सॉर्ट इट in descending order and then take the top two, then the next two, then the next two, then the next two, till it's possible. So let me go back to code also. यहाँ भी मैंने मल्टी लाइक आई हैव यूज्ड मल्टीसेट, बट एक्चुअली मल्टीसेट इज नॉट absolutely required. You could have done without it also. So let's see what I've done here, right? So what I've done, I've declared a multiset. You could declare a vector and sort it. I just wanted to keep it sorted, तो मैंने सीधा multiset बना दिया. What I've done is I'm going over the array, calculating the contribution. तो IT XOR के add होगा, IT subtract होगा. So this is the contribution. So this contribution I've pushed, I have inserted into this multiset. तो ये मल्टीसेट ऑटोमेटिकली लार्जेस्ट कंट्रीब्यूशन वाले को सबसे ऊपर ले आएगा. सेकेंड थिंग, अगर मैं इसको जोर नहीं करता हूं तो जो सम होगा वो मैंने आंसर में रखा है. तो आंसर इज नथिंग बट सम ऑफ ऑल द एलिमेंट्स. अभी व्हाट आई एम डूइंग रिपीटेडली, टेकिंग टू एलिमेंट आउट. ठीक है, तो मल्टीसेट से टॉप टू एलिमेंट्स निकाले जिनसे मैक्सिमम कंट्रीब्यूशन ऐड होगा अगर मैं जोर वैल्यू लेता हूं. सो आई हैव टेकन द टॉप टू एलिमेंट्स. अगर उनका सम पॉजिटिव आता है, लाइक इफ दे सम अप टू अ पॉजिटिव वैल्यू, दैट मीन्स दोनों का मिला के कॉन्ट्रीब्यूशन पॉजिटिव है, तो आई एड इट टू द आंसर. अदरवाइज आई ब्रेक फ्रॉम द लूप, बिकॉज अब जो भी बच गए उनका टोटल कॉन्ट्रीब्यूशन नेगेटिव होगा. इफ आई जॉर देम तो आई बी इन अ लॉस. सो इन अ वे व्हाट आई एम डूइंग, लाइक जस्ट टू समराइज इट, पहली बात तो ट्री की जरूरत नहीं है, बिकॉज एनी टू नंबर्स यू कैन लिटरली जॉर. अगर जॉर किसी नंबर को करते हैं, सो व्हाट वुड हैपन, आंसर में से आंसर में उनका जोर ऐड हो जाएगा, बट द ओरिजिनल वैल्यू वुड बी सब्ट्रैक्टेड. तो दिस थिंग कुड बी पॉजिटिव और नेगेटिव. अगर अगर जोर करने से नुकसान होगा तो इट माइट बी नेगेटिव, फायदा होगा तो इट माइट बी पॉजिटिव. इन वैल्यूज को वी हैव सॉर्टेड इन द डिसेंडिंग ऑर्डर एंड वी आर टेकिंग इट इन टू पेयर्स. तो टिल द टाइम you have at least two elements in the array and beginning element has positive contribution, तब तक what do you try to do, you try to take two contributions एंड सी इनका टोटल अगर अभी भी पॉजिटिव कंट्रीब्यूशन देता है तो आई ऐड दैट कंट्रीब्यूशन टू द एरे. अदरवाइज आई सिंपली ब्रेक फ्रॉम द लूप, बिकॉज अब कंट्रीब्यूशन आने खत्म हो जाएंगे एंड आई फाइनली रिटर्न द आंसर. सो एक्चुअली इसमें पूरे एजेस का कोई रोल ही नहीं है, लाइक दीज वर नॉट एट ऑल रिक्वायर्ड. द ओनली थिंग रिक्वायर्ड वॉज दीज टू, actually the nums, and based on that we could do our calculation. Cool. So that is about all four problems. If I talk about the time complexity, मैंने यहाँ multiset use किया है तो it would be n log n, right? Even if you would have used vector and sorted, then also it would have been n log n only, because sorting also takes that much time. But I felt this was an easier problem once you फिगर आउट कि हम किसी भी दो नोड को जोर कर सकते हैं, राइट? देन इट्स जस्ट अबाउट कि यार किसको जोर करने से फायदा है, किसको जोर करने से फायदा नहीं है, एंड पेयर्स में ले सकते हैं, राइट? सो इट बिकम्स अ मच मच सिंपलर प्रॉब्लम. Great then. If you like the video, just like it, right? And do subscribe to the channel if you are new here. We go live after every contest. Today there were some technical difficulties, like the stream stopped in the middle, it went black in the middle, and right now I cannot see the chat, so I cannot literally see any questions that you guys are posting. So yeah, if you have questions after this also, just put them in the comment section. I'll answer all of those, right? So yeah, great. Let's see you tomorrow morning where we'll take up tomorrow's weekly contest. Bye bye.